Good morning, my dear students. What are the main topics we discussed in our last class? In our last class, we discussed about measurement of mass and measurement of time. We discussed about the measurement of mass. What is the SI unit of mass? It is kilogram, the symbol kg. Multiple units of mass, quintal and metric ton. 1 quintal is equal to 100 kilogram. Then 1 metric ton is equal to 10 quintal. It is equal to 1000 kilogram. These are the two multiple units. We already discussed these things. Then next we discuss sub-multiple units of mass. Milligram and gram. 1 gram is equal to 1000 milligram. So 1 milligram is equal to 1 by 1000 gram. We have to study these portions very well. Then after that we discuss the two devices for measuring mass. What are the two devices for measuring mass? First one, beam balance and electronic balance. Then we discuss about the main parts of electronic balance. Three main parts are there. What are the three main parts? Load cell, structure and the signal conditioner. I hope all of you study these portions. After that we discuss about the time. We discuss about time. The SI unit of time is second. We can written in small letter s. After that we discuss the bigger units of time, hour, day, year and minute. Two measuring devices we will use for measure time. They are watch and pendulum clock. At last we discuss about the devices for measuring time interval. They are stopwatch and stop clock. For getting accurate measurement we will use electronic balance. These much portions we discussed in our last class. I hope all of you studied these portions very well. Anyway, today we are discussing the last physical quantity, that is temperature. Okay. Today we are discussing about the details of the physical quantity, temperature. If we touch a hot object, we will feel very hot. If we touch a cold object, we will feel very cool. What is the reason? This is because of the direction of heat flow. If we touch a hot object, heat passes from that object to our hands. The same way, if we touch a cold object, the heat passes from our hands to the object. It depends the direction of flow of heat. So, the hotness or coldness of an object depends on the transfer of heat. Heat always transfers from higher level to lower level. If we touch a hot object, we will feel very hot. The same way, if we touch a cold object, we will feel very cold. This is because of the heat transfer. If we touch a hot object, the heat passes from the object to our hand. If we touch a cold object, heat passes from our hands to the object. Therefore, the hotness or coldness of an object depends on the transfer of heat. Heat is always transferred from higher temperature to lower temperature. So, the temperature means the degree of hotness or coldness of an object. The SI unit of temperature, we already discussed that one. What is the SI unit of temperature? Kelvin. In shortened way, we can written as capital letter K. There are two more units of temperature we will use. They are degree Celsius and degree Fahrenheit. The degree Celsius we can written as degree Celsius and degree Fahrenheit we can written as degree. Look this table. Here we can see the three units of temperature. First one Kelvin, the symbol capital letter K. Second one degree Celsius. The symbol degree C. It was given by the scientist Andrew Celsius. And we can see the symbol of degree Fahrenheit. It is named after the scientist Gabriel Daniel Fahrenheit. The unit of Kelvin is never written as degree Kelvin. Here we can see the ice point and steam point of water and the number of degrees in between the ice point and steam point on various scale of temperature. We know that three scales are the Kelvin, Celsius and Fahrenheit. Ice point means melting point. Steam point means boiling point. Okay, here ice point of water, by using Kelvin scale, it is 273 Kelvin and boiling point is 373 Kelvin. There are 100 divisions are there in between this ice point and steam point. 373 minus 273. We know how many divisions are there in between? 100 divisions. So, in between the ice point and steam point, 100 divisions. Then if we are using the Celsius scale, we know that what is the boiling point of water? In Celsius, 100 degrees Celsius. What is the melting point of what ice? Melting point, 0 degrees Celsius. So, by using Celsius scale, ice point is 0 degrees Celsius and the steam point is 100 degrees Celsius. So, in between the ice point and steam point, there are 100 divisions are there. Next, we are using the Fahrenheit scale, the third scale of temperature. By using the Fahrenheit scale, it will show the ice point of water is 32 degree Fahrenheit. The steam point 212 Fahrenheit. So, in between the ice point and steam point on Fahrenheit scale, there are 180 divisions. Okay. So, what is the ice point of water on Kelvin scale? 273 Kelvin. What is the ice point of water in Celsius scale? 0 degrees Celsius. Then steam point of water in Celsius scale 100 degrees Celsius. The steam point of water in Fahrenheit scale to 12 degree Fahrenheit. So, you have to study the temperature on various scales. That is an important one. Okay. Then how many divisions are there in between ice point and steam point in Fahrenheit scale? How many divisions are there? 180 divisions. How many divisions are there in between ice point and steam point on Kelvin scale? 100 divisions. How many divisions are there in between ice point and steam point in Celsius scale? That also 100 divisions. Therefore, 1 degree on Celsius scale is equal to 1 degree on Kelvin scale, because in both scale contain 100 divisions in between ice point and steam point. 1 degree rise on Celsius scale is equal to 1.8 degree rise on Fahrenheit scale. There are 100 divisions in between ice point and steam point in Celsius scale. Therefore, Celsius scale is known as centigrade scale. The Celsius scale is known as centigrade scale. Give reason. What is the reason? Because there are 100 divisions are there in between steam point and ice point. Therefore, Celsius scale is known as centigrade scale. Let's see this table. Here is point, the steam point and the number of degrees in between ice point and boiling point on the three scales are as follows. Kelvin scale, ice point 273 Kelvin and steam point 373 Kelvin, and in between the ice point and steam point there are 100 divisions are there. In Celsius scale, ice point is 0 degrees Celsius, steam point 100 degrees Celsius. The same way, in between the ice point and steam point in Celsius scale also contain 100 divisions. Then the last one, in Fahrenheit scale, the ice point is 32 degree Fahrenheit and the steam point is 212 degree Fahrenheit, and there are 180 divisions in between ice point and steam point. Next we are discussing the devices used to measure temperature. We already know which device we will use for measuring temperature. Thermometer. Thermometer is the devices used to measure temperature. In chemical laboratory, we will use laboratory thermometer. For clinical purpose or for doctor using thermometer is known as clinical thermometer. So, here we are discussing two types of thermometer. First one laboratory thermometer, the second one clinical thermometer. You can see the picture of laboratory thermometer here. This is the laboratory thermometer. This laboratory thermometer containing glass capillary tube with a bulb. The bulb is filled with mercury and it contains long stem. The stem contains the marking from minus 10 degrees Celsius to 110 degrees Celsius. If we are keeping this bulb into boiling water, it shows 100 degrees Celsius. If you are keeping the bulb into melted ice, it shows 0 degree Celsius. Look here, this is laboratory thermometer. We can see here a glass capillary tube with a bulb at one end. This bulb is filled with mercury. The long part of this capillary is called stem. The stem has marking from minus 10 degrees Celsius to 110 degrees Celsius. 0 degree mark is at the level of mercury in the capillary tube when the bulb is placed in melted ice, while 100 mark is at the level of mercury in the capillary when its bulb is placed in the boiling water.
Let us now measure the temperature of hot water kept in a beaker. Take a laboratory thermometer. Immerse the bulb of thermometer in hot water. See the shining thread of mercury moving up in the thermometer tube. After some time, the mercury thread will stop rising and stand at one place. Read the temperature on thermometer tube which corresponds to the top of mercury thread. This is temperature of hot water.
Next we are discussing the another type of thermometer that is known as clinical thermometer. We already know that clinical thermometer is doctors using thermometer. The doctor using thermometer that is known as clinical thermometer to measure the temperature of patient. It has a slight bend or kink in its stem. It is known as constriction. What is the use of this kink or what is the use of this constriction? It prevents the backward flow of mercury. The temperature of a healthy person is 37 degrees Celsius. Okay, this clinical thermometer is we will use under the armpit or just below our tongue. If the temperature is higher than 37 degrees Celsius, then the person is suffering fever. To measure the temperature of the patient, we will keep this thermometer either under the tongue or just below the armpit. If the person suffering fever, it shows the temperature higher than 37 degrees Celsius. Now we discuss the four types of physical quantities: length, mass, time and temperature. These four physical quantities are known as fundamental physical quantities. But some other physical quantities like area, volume and all, they are known as derived physical quantities because these are expressed by using the measurable physical quantities like length, mass, time and. So therefore, this type of quantities are known as derived quantity. The physical quantities like length, mass, time and temperature are independent of each other. They are not related among us themselves. Such quantities are called fundamental quantities. Area, volume, speed, etc. are the quantities which are expressed in terms of measurable fundamental quantities like length, mass, time, etc. They are called derived quantities. Next we are discussing the measurement of area. The total surface occupied by an object that is known as area. You already studied in mathematics the area of different shapes. Let's see some important shapes and their area. Area of square, side into side. L square. The area of rectangle, length into breadth. The area of triangle, half length of base into height, half LH. The area of circular lamina of radius r, pi r square. The value of pi, 3.14. Now we discuss some important formulas of different types of some shapes. The SI unit of area is meter square. We can written as m square. There are some multiple units and sub-multiple units of area. The decameter square, hectare and square kilometer are the multiple units of area.
Measurement of area. The extent of the surface occupied by an object is called its area. Area is the region enclosed within the boundaries of a two-dimensional figure. A two-dimensional figure has only two dimensions, namely length and breadth. Squares, rectangles, triangles and circles are all examples of two-dimensional figures. Measuring area of regular shapes. The area A of a regular surface such as squares, rectangles and triangles can be calculated by using specific formula. 1. Area of a square is equal to side into side is equal to side square. 2. Area of a rectangle is equal to length into breadth. L into B. L is equal to length, B is equal to breadth. 3. Area of a triangle is equal to half into B into H. B is equal to base, H is equal to height. Unit of area is square meter, meter square. 1 meter square is the area of a square whose each side is 1 meter. When we need to measure the area of a big surface like a room, a garden or a building, we need bigger units of area like air and hectare. 1 air is equal to 10 meter into 10 meter is equal to 100 meter square. 1 hectare is equal to 100 meter into 100 meter is equal to 10,000 meter square. The areas of countries and continents can be measured in square kilometers. Kilometer square. 1 square kilometer is equal to 1 kilometer into 1 kilometer is equal to 1000 meter into 1000 meter is equal to 10,000 meter square. The area of a very small surface, like the area of the base of a geometry box, can be measured in square centimeter. 1 square centimeter is equal to 1 centimeter into 1 centimeter is equal to 10 millimeter into 10 millimeter is equal to 100 millimeter square.
Multiple units of area. 1 decameter square is equal to 100 meter square. 1 hectare is equal to 10,000 meter square. Can write 10 raised to 4 meter square. 1 square kilometer is equal to 1 square kilometer is equal to 10 raised to 6 meter square. These are the multiple units of meter. You have to study only this. So multiple units of area: decameter square, hectare and square kilometer. 1 decameter square is equal to 100 meter square. 1 hectare is equal to 10,000 meter square or 10 raised to 4 meter square. 1 square kilometer is equal to 10 raised to 6 meter square. Today we discuss one important physical quantity, temperature. 3 units of temperature: Kelvin, degree Celsius and degree Fahrenheit. Then we will use thermometer for measuring temperature. We discuss here two types of thermometer. One is laboratory thermometer and the another one is clinical thermometer. The laboratory thermometer contain marking from minus 10 degrees Celsius to 110 degrees Celsius. After that we discuss the one derived quantity, that is area. The SI unit of area is meter square. We can written as m square. The multiple units of area, decameter square, hectare and square kilometer. I hope all of you cleared today's class. Thank you. Have a nice day.